name is Matt Ho. I'm the CTO for Loyal3. And today I'm going to talk to you about one of my favorite open source platforms, Twitter's Finagle. Well, in Twitter's own words, Finagle is a network stack for the JVM that lets you build RPC applications in a protocol-agnostic way. Well, why do we need another one of these things, you might ask? If I take you back a little bit, long ago when we were first writing web applications, or maybe when a company first starts writing them, they're very simple. You've got a web application, talks to a database. Pretty easy. But as time goes on, what you find is that you add complexity to the system. It's not enough just to talk to the database. Now you introduce a services layer. You might have an API server as an abstraction. So you've got service A and service B. But it doesn't stop there. It goes on. Right? You decide that, oh, service B really needs to call these other services. Maybe we need a queuing solution. Maybe we need to call this other external service. And your environment grows. Maybe you decide that at that point, now is the time to have a mobile system. So you add the mobile interface, and your environment grows again. Well, what happens is before not too long, boom, you've actually got a pretty fully fleshed environment. A distributed processing system looks a lot like Tumblr. Looks a lot like Facebook, Twitter, a lot of the systems that you see. So in addition to that, not only do you have lots of services, but most of these services have their own protocols. You got a little bit of HTTP here, a little bit of Thrift over there, some JDBC, Cassandra, Redis, etc. And typically, each one of these protocols comes with its own libraries, jars, etc. to go manage it. With all this stuff, hey, what could go wrong? The reality is, as you heard from the previous talk, there's actually quite a bit of stuff that can go wrong. I'm not going to bother to go through this list. The previous talk, I think you did a great job of going through. But there's a bunch of stuff that happens, and that can happen. So what is a solution to this? Well, the way I think of it is, I think of Finagle as an expressive network library to develop these applications. So not only does it handle the networking layer, but it also handles some of the core libraries and services underneath that. Well, what does that mean? Finagle actually has quite a few pieces to it. And what I'll do is I'll break up this talk into two parts. One is as an asynchronous futures framework. And the second is as a common infrastructure that you can build your client and server applications on. So let me first turn to the asynchronous platform. Finagle's nice. It reduces the world and says if you're going to be doing asynchronous RPC development, there's only three basic constructs you need to worry about. A future, a service, and a filter. The first one, a future, we've heard a number of talks on it now. It's a computation that has not yet completed. It's more or less a promise of something to be done later. Most of the time, it's either non-blocking or it's implemented through either non-blocking code or a thread pool. In the case of Finagle, Finagle almost entirely uses non-blocking code. So if you've heard of frameworks like Event Machine for Ruby or Twisted for Python or node.js, it's the same idea. Rather than creating a large thread pool to handle these asynchronous calls, what it does is use a small number of connections or a small number of threads to basically manage this. So it's using non-blocking code almost throughout the entire thing. It gives you the option if you want to use a thread pool, you can, but by default, it's going to be non-blocking. Okay. I think the thing that the previous speaker alluded to is that one of the challenges with futures is currently there's a lot of choices. You've got the Twitter futures, the concurrent, the actors, Akka's version, Scala Z. There's a lot of versions of futures. What I'm going to be focusing on, as you might expect, is just one of them. Even though there's a bunch of dialects, right, the dialect that I'll be talking about is the Twitter future. And what we find is since so much of our stack is built on this, there's not a lot of interoperability for us. We just kind of picked this one and went with it. I find sometimes the easiest way to grok the way it does is just to give you a bunch of examples. So I'm going to go through and talk about different things you can do with them. So here's a really basic example. Val future of user is take this user service and look up an email. So it's just a basic thing of look up this user by email and give me a promise of the future when it'll be done. Now let's see what we can do with that. The first is I can say, well, forget this asynchronous stuff. I just want to treat it like regular blocking code. So I can call get on it, and that will just return me the user object. So I can treat it as if it was synchronous. This is really good for testing, where you don't necessarily want to have to wait. You just want to say, go do it now. But in the real world, we don't want to block. We want to do things in parallel. So here's a case where I might have a cache service, and I want to look up 3 key values, key 1, key 2, key 3, and I want to do all those simultaneously. So when I make these 3 invocations, none of these block, so I immediately drop down to this location. So that's kind of nice, but I really want to be able to, at some point, maybe render a web page. So I want to know when all 3 of these are done. And I don't want to have to wait and do a get on each one of these sequentially. What I'll do is I can combine them together, take future 1, future 2, future 3, put them into a sequence, and then just say, join them together and just say, tell me when this is done. So now when finish.get is called, when this finishes, it means that all the futures that are composed in there will have finished. It's a nice handy shortcut. In other cases, I might want to transform a future. I've got this user that we talked about. We looked him up from the email, and so now we've got this reference, but now I want to create a session off of it. So I can use just a standard collection operation, a map, and transform that user now into a future of a session. It gives me a really easy way of composing and chaining these things together. Really my goal in kind of machine gunning through these is to give you a sense that once you've got it into this format, it's not very difficult to work with at all. There's a lot you can do with it in terms of transformations, in terms of chaining. It's a very simple way to think about things. It doesn't add a lot of overhead to your code. It keeps it very simple. There are cases where you might have do this, then do this, then do this, then do this. And as we've seen in other talks, you can use a for comprehension to basically turn that chain into a singular operation where you can use a for comprehension to just go through and say, here, first do this, pass it to this, and then render the result. Here's one of my favorite things to do. If you guys have ever done performance testing, what you'll notice is that usually the response rates look pretty good, and usually when you get to the 90th, 95th, 99th percentile, your curve goes from flat to straight up, right? There's always that 1% out there, that 0.5% that responds really badly, right? Well, an easy way, a way to get rid of that is instead of making a single request and having that long tail out at the end, it turns out if you make 2 requests for the same service, let's say I'm looking up something from my cache or I'm looking up something remotely, if I can afford to if the backend can handle 2 calls, if I make 2 simultaneous calls and just take the first one that comes back, turns out that long tail at the end, at the 90th percentile, 95th, and 99th, goes way, way down. Your curve goes from something that looks like this to something that looks a lot smoother. And so the effect of that is the response time to your users is much, much better. How much code does that take with Finagle? Well, let's say I have these 2 things I want to look up in parallel, future 1 and future 2. I can now just say, here's a sequence of 2 things I want you to look at, and the number could be any number. Look up 5, look up 6 at a time, whatever. And what I want is tell me I want to select the first one that comes back as my result. What it returns to you, this object, I didn't want to do the signature because it's kind of a long signature, is it gives you the result of the first response and then all the remaining responses just in case you want to cancel or do something with them. So in this case, I just said, give me all the responses, give me the first one, and here's the value. Again, the beauty of Finagle in my mind is it made it very, very simple to do this without a lot of complexity. Right? This is something that you could easily get your developers to go do. Well, let's keep adding complexity to this. Sometimes I want to get back to my users, and let's say I've got that long tail still, and that long tail is somewhere out there at 15-second response times. I don't want that. I don't want to respond to my user in 15 seconds. If it takes that long, I want to go do something else. So what I want is to say after maybe 5 seconds, stop it, and let me do something. Come back to me. So I can just take that future, same thing we had before, the lookup, And I could just say, within this timeout, within 5 seconds, you have to finish or it's an exception. Right? So now I have not only the ability to control that long tail, but I can say, well, my service level is a 5-second response. I'm going to give you something at the end of 5 seconds. And again, not much code to do it. Well, sometimes problems happen. Right? So let's say there's something wrong and maybe the service is down. With the future, I can just say, handle this exception, and it looks like many other sort of exception handling block. And I can handle the exception here and then return the same type and go on my merry way. So as far as the service is concerned, I can deal with something, return a future string in this block, and life will just keep going. Right, so it gives me the ability to, maybe I want to retry through something else, maybe I want to try a different key. Whatever the option is, I have the ability to go do it. So that's really futures in kind of a quick nutshell, and that's the first leg. The second leg is service. So Finagle treats everything as a service. So if you're talking to a remote thrift application, if you're talking to a REST API, if you're talking to whatever it is that talks thrift, protobuf, Redis, Memcache, whatever. It's the thing that oops, wrong direction. A service is the thing that handles the RPCs, and takes the request and gives back replies. It will always conform to this signature. Now, if you actually look at the code itself, there's a little bit more to it. I've simplified it to make it easier to see here. But ultimately, service, it has a request type and a response type. And depending what the protocol is that you're talking, for an HTTP, you might end up with an HTTP request, HTTP response. If you're talking Redis, you might end up with command and reply as the instances of objects. Depending on the protocol, the request and response types will be the same, but the interface is exactly the same. It's always service, request response that has an apply. So let's make a web server out of Finagle. So here's the toy version of creating a web server. So here's my service. My service is basically something that will respond to anything and just say OK, and gives you a blank page back. Right? It's the toy version that you might see on like an event machine or a node.js. And all I'm doing is saying, here, give me a new service, and I'm creating a new future and giving you back a response with a version of 1.1 and a status of OK. Now let's create the actual web server. So I can use this Fluent interface and say, I want a server. It's going to talk HTTP. I want it to talk on port 5000. I'm going to call it web server, and it's bound to this service. So in this case, this is a web server implementation, but this might be a thrift implementation, protobuf, etc. This doesn't change. It's the same. So once I run that, I've got my asynchronous non-blocking server up and running. What's the flip side if I want to do a client? Well, a client, turns out, has another builder to help you create it, and it looks awfully similar. So client, then, you specify the protocol. In this case, we want HTTP. How long do we want to be able to take to connect? What host do I connect to? How many concurrent connections will I allow before back pressure starts kicking in? Boom, create this client. And now to utilize this Finagle client, I can create a new default HTTP request, just a simple thing. Here is a GET request for the home page. And I fire that into the client, and it gives me back a future response. Now another thing that I love about this is because there's a very simple interface for services, this can be mocked up tremendously easily. So when we're testing the application, if we want to do an actual live connection, or if we want to do a fake connection that just implements this, it's very, very easy to just swap one out because the client doesn't really care. When you're invoking this, you just want something that implements this interface. So just for giggles, I'm going to change up that web client, and now we're going to make it a Redis client. So now we've basically taken the previous code, swapped it, so now it'll make a simple Redis request for my key. And you notice that nothing's really changed, or not that much has really changed. In fact, here's the only changes that we've made. As you can see, HTTP request, HTTP response has changed into command and reply. The codec is now changed to Redis. And instead of creating a new HTTP request, we're now creating a Redis command. So get, delete, whatever the Redis commands are, those are the things that we're sending in. And instead of getting an HTTP response, we get a reply back. It's really nice to have your team just only need to learn things one way. And once you've learned things the one way, regardless of the protocol that you're working with, you have the same conceptual model. It always works the same way. And this is just as asynchronous as the previous bit was. If we replaced it with thrift, again, it's still non-blocking and asynchronous. So the last leg of what Finagle is built with is a filter. And a filter can basically be thought of as something that transforms a service. A common filter might be something like authentication. So instead of taking an HTTP request and returning an HTTP response, maybe instead you transform that HTTP request to an authenticated HTTP request. Right? Just like service, it also is a future, so that it'll be non-blocking. It's a great way to be able to decompose services into phases. For example, let's say you have something like you want to do rate limiting. Maybe you want to do rate limiting for your internal servers. Maybe you want to do it for your external servers. You can implement the rate limit as a filter, and then whatever sort of RPC you have, client or server side, you can just say, oh, great, stick this rate filter on, and boom. You don't have to rewrite the rate filter as the memcache version of it, and the thrift version of it, and the Cassandra version of it, etc. Okay. So that's part one of basically Finagle as the asynchronous platform. It makes it very, very simple to write a futures-based non-blocking code. The second part, and for me, this is almost more exciting than the first part. It's a common framework to build things on. There's a bunch of things that I don't want to have to write over and over again every time I create a new RPC call. So there's connection pooling, load balancing, failure detection, failover, distributed tracing, service discovery, statistics, SSL bindings, etc. What typically I would have to do without a Finagle is for every single protocol, they usually have their specific way of handling these things, right? There is, how do you do service discovery with memcache? Well, it works like this. How do you do service discovery when it comes to finding your thrift services? Kind of works like that. So in each one of these environments, you have to have a different way of doing it. And it means you have people that are more fluent with, hey, I'm just really good with configuring memcache, or I'm really good with configuring this, that, or the other. It's just nicer to have it done one way, and the code can be shared. So these are client-based features. It turns out that much of the pain with RPC applications is not server-side, it's really client-side. What do you want the client to do if things go wrong? Do you want it to retry? Do you want it to reconnect? How long should it wait? Things like that. That said, on the server side, Finagle still has a set of features that it offers. Things like back pressure, server registration via Zookeeper, distributed tracing, the native OpenSSL bindings. And all these things, just like the futures code was really easy to access, Finagle has made it really easy to access these features on the back end. What I'll do is I'll go through a few examples of those. The first is, let's go through just simple round robining. So now I have Redis configured, and it's the same code as before, but now I have a comma-separated list of hosts. This is just a very simple case of try one of these guys, and wherever you get the answer, great. But let's say I want something a little more sophisticated. Maybe I don't know exactly what my hosts are. My host might be configured in Zookeeper or some external service. So Finagle has this concept of a cluster. And so here's now the same Redis configuration. I'm not going to bother with the configuring of the Zookeeper cluster. There's a bunch of work involved in that. But all you're telling Finagle is ultimately just go find your information from this cluster. And the implementation of the cluster will figure it out. So if you want to write different strategies in terms of how you should load balance, how you should get connections, should it be based on the most number of connections, response times, network topology, etc., There's a common way to do that, regardless of protocol. What I did here is I just sort of highlighted that just changing it from a simple round robin to this, you can see, is only just a few lines of code. Now granted, this is a bunch of setup to get the Zookeeper up and going, so I kind of ignored that part. But to set up the cluster itself is not too much. Let's take a look at services like Zipkin. So Zipkin is something that is another Twitter open source project to do distributed tracing. Now this one is a pain to set up, the actual Zipkin service, but to integrate it in with Finagle is actually pretty simple. And so Finagle, one of the options you have is a tracer factory. And by default, you get the null tracer factory, which does nothing. But in this case, I just want to trace to Zipkin. So in it goes. And if you get Zipkin set up, you get this really nice looking, kind of tree view of all the different services you've called, how long they've taken, the actual operation time. So I could see, whoa, hey, there's something going on here, and hopefully this is supposed to take this long. But as your environment becomes more distributed and you have more services, it's just hard to figure out where the heck did the problem go. So this is kind of becoming a theme. It's really just add the magic line and the services available. So for Ostrich, I'm not going to bother again to show you the configuration of Ostrich itself, just the way it plugs into Finagle. So if you want to do the gauges, metrics collection, all the things that the Tumblr presenter mentioned, you get it out of the box if you just say, here, stick it in Ostrich. And again, cross protocols, which is really, really nice. Here's a tool. I don't believe, this is not Ostrich's normal way to render the data, but this is just like a rendering that Twitter uses of the data that comes out of Ostrich. It keeps a lot of data, and it's nice that you don't have to do much to get this. So, in summary, the way I think about this is, whenever we're writing application code, there's a bunch of pieces that we're writing. We're writing business logic, the operational code, the drivers, and we're writing it, along many different services. When the team's writing the business code logic, I love it. That is time that is moving the business forward. It's great. When we're using third-party drivers, I love that too, because it's code that we didn't have to write. We picked up open source from some other party. When we have to write operational code separately for each one of these services, this is when I go nuts. Because we're doing error detection, logging, service discovery, failover, et cetera, and we're repeating the same things over and over and over again. What I prefer is just all of these things to be compacted together. We have the team learn one style. We have that sort of that similarity, so people can just learn this and not have to worry about the rest of the details. They can focus and spend their time up here, and then we can have a smaller team work on this. So I've actually blazed through way faster than I thought. Questions?
We had a collection of, say, Jack's web services.
A collection
if we had a collection of, say, Jack's web services, like Jersey.
Okay.
We could just bolt this right on top of that, right? There's no
so what
problems with like a lot of weird legacy stuff.
If you have a Jack server, so typically that'll run within a servlet container, and it has its own little stack for doing things. So one of the challenges with Finagle is you really get the most benefit when you just make your stack Finagle, and you basically say everything from business logic on down is just Finagle. So if you were to use Jax, then you would have to replace some of those Jax things with Finagle. I mean, you can get some light benefits. So if you wanted to use Finagle's thread pooling, you'd be able to use the future component of that. But I don't know if that's as valuable as being able to use the whole Finagle stack. If you wanted to, let's say, use the distributed logging and the metrics, you could use Ostrich, but Finagle wouldn't help you very much there because it wouldn't be pre-integrated. Finagle works best if you can just take the thing out of the box, say, okay, great, here's the stack, we'll use it as is. Yes?
So I noticed the service signature, the apply method, basically the request and the response were specific to the protocol type.
Yes.
I wondered if you could comment on that.
So every protocol has its own request response type. Whether you're talking about a synchronous HTTP or if you're talking about comment, each one of those will have its own distinctive ones, which is, so for example, I included the Redis example. So Redis, instead of HTTP request, HTTP response, has command and reply. And that's part of the codec. So the codec is really what determines like how to interpret the protocol. Does that answer your question?
Yeah, so the part that you're going to reuse between like a Redis interface to your business logic or an HTTP interface, that's yet another layer down, I guess.
Well, so here's some examples of things you might reuse. Let's say you had service discovery, right? You could just write service discovery once, plug it in, and it doesn't matter if it's Redis or HTTP. Let's say, for example, you have let's say you want to be able to throttle usage of some sort. So in that case, you could create a filter, and you would write the filter using a generic type, so that regardless, you would just specify that this is for command and reply. But the filter itself doesn't care what the underlying protocol is. It just knows that every time a request comes in, I'm counting. You might do that with, for example, authorization. So let's say that there's an authorization scheme, and once the person's entered your web application, you have some sort of context where you manage the fact that they're authorized. And so now when you're firing off these requests to remote services, regardless of whether or not they're thrift or protobuf, like you could take advantage of the fact that you already know about the authorization. So there's a bunch of things you can do that are common among things. So another might be that you have a retry system where if it fails, you try again, but you don't try again at the same interval. You might have a back-off strategy, where it's half a second, then 2 seconds. And so you could do that with Memcache, Redis, protobuf, et cetera, and you only have to write it once.
So the example where in these servers you put in like a series of server addresses, or maybe you discover a variety of those from Zookeeper. You said by default that does round robin. I mean, can you configure to say hash on key amongst that collection of servers or something like that?
Sure. Let me get to that slide. Okay. So here was the example where this is the default round robin example. And the reason it's used is it's the most common one. So you could think of almost this as syntactic sugar. It's not really, but I mean, you could think of it that way. If you want to do something like what you're suggesting, there's a bunch of cluster implementations already built out of the box. You would just pick the cluster implementation that most closely reflects what you want to do. If it's based on number of concurrent connections or whatever. So the cluster would be the way to do that.
I guess like the hash on key seems like it would require understanding of the protocol level to say somewhat.
Oh, I see what you're saying. I see what you're saying. So, like if you want to do, say, a consistent hashing scheme with that, I'd have to think about that. Can I get back to you?
Sure. I guess I get the impression, is this more for just the general reliability and not so much that protocol level stuff?
I haven't actually written a custom cluster implementation. My understanding, though, is you actually get access to the request object. So I'm willing to, my gut says, like, I call it 75-25, that you would still use the cluster implementation, and they would have access to the actual request, so you could peek inside it to make that decision. But don't hold me to that.
Can you hide the marshalling and unmarshalling of response behind Finagle too, or do you have to do it on your own or outside Finagle?
Can you do the marshalling and unmarshalling?
Let's say you're getting JSON back and I want to convert to like an object. Can I hide that behind Finagle so I don't need to know if it's coming JSON or whatever, and I just get an object out?
Okay. So there's a couple ways to do that. The first is you could write your own codec, right? If it's a very specific thing, so you take the HTTP codec and kind of make your own specific derivative of it. A second is you could create a filter that takes a generic HTTP request and converts it into your JSON-based one. I was actually playing around creating a library that was Finagle-based to access all the AWS services. And then what I found was easy is just also do it at the application layer. Is just take the straight HTTP and do a simple transform on it. So there's 3 ways you can go: the codec, the filter, and at the application level. I think codecs are, for me, they're a little more challenging, so I would probably go with the filter or the application level, but it's whatever you're comfortable with.
given SIP14 and that Scala Actors future, Akka Dispatch future, Play Frameworks future have
Yes.
already gone, when will Twitter util future follow?
That's a good question. So I know Marius put out the 210, a version of Finagle that compiles with 210, but it doesn't actually extend from the 210 tree. I don't know when they're going to do that. From my point of view, I'm not as worried about that because for us, it was easier to go with an entire stack. When we have interoperability, I worry about the problems like the Twitter or the Tumblr person mentioned, that for the time being, we don't have cases where we combine the two. We just have the one. And so I guess you could write a transformation, but the answer is I don't know. I don't know when.
It would be nice if, for example, from Play you could use Finagle components and
Oh,
then
absolutely.
you could just complete the request with the Finagle future, right?
Absolutely, I don't know.
Just a quick question of introducing team members to futures. I really like futures, but I've found that often when you first introduce somebody to futures, they get really frustrated that none of their debugging tools work anymore or not the way they're used to. I was wondering how you get people through that and past that.
Well, the challenge that we've always found with using them is normally you're used to having the full stack trace, and you can see all the things that are going. But all of a sudden, once you start using code asynchronously, you find your stack traces are very, very short. And so it's difficult to figure out where you've come. I'd like to say we have a better solution, but really the debugger becomes a much better friend of yours, especially if the service is localized. And then past the debugger, logging becomes a really good friend. And so I'd love to say that we have a more sophisticated answer, but you know, that's pretty much it.
Do you have any support of prioritization of futures, or changing their sequence if they live long, for example?
If they live long, like
in the queue. So there are a lot of features submitted, but some of them are not processed for a long time. I mean, we could prioritize them to process right away.
oh, I see. Prioritize a feature once it's already in the list. At this point, there's only really limited functionality for that. So one is you can say, give me the first feature that responds, and then it's up to you to do whatever you want with the rest of the futures. And if you're worried about the future being very long running, you can specify a timer or timeout on the future. So you can, as you construct it, you basically say, this needs to respond in 5 minutes, in 30 seconds, or in whatever time period you want, or else timeout. I don't know if there's anything more detailed than that. So I think the question was on integrating Dapper.
Yeah, like if I wanted, referring to the problem of trying to correlate what went in and what went out.
Right.
Yeah.
So I'd love for someone to go do that, and that's, I know that Zipkin comes pre-integrated, which has a lot of the concepts from Dapper, but I haven't, it's not something I've dug into myself and looked through the code of. Last question.
Is retry part of the stack, or is you have to do that in your user code?
It's in both places, depending on what retry means for you. So the simplest way to implement retry on the client is there's in fact a line here that you could add that says if you just add retries and you just pick a number. So that's at the basic sort of connectivity level. If the connection fails, it will do the retry. But if you need something that's a little more application aware, then you're going to have to write that.
One more? Just somewhat related. What if you want to have support for queuing behavior? Let's say something similar to a message queue. Would that be a part of the support, or is that totally a user responsibility?
For queuing behavior. So whenever you throw things into a future, it will basically get queued up to do, but I wouldn't treat it like a real queue. It's not like
I asked this more because I heard something from the previous talk where if you bring let's say your server side down, the client side will be able to queue up certain things to up to an hour. I don't know if that kind of behavior we can get out of this, or...
That's actually, I think, a separate tool he was mentioning. So okay. If you look at Zipkin, the distributed tracing tool, it uses an open source project called Scribe. And what Scribe does is it's just a way to collect data. And if the endpoint that Scribe is writing to is down, it'll just buffer things. And when the target is up, it will. So that's pretty much another project outside of Finagle.
Thanks.
All right, well, thank you very much.